All right. So the word of the day is what? Cancel. All right, because we're gonna have stuff in the numerator, stuff in the denominator, and stuff can cancel. So that'll be fun stuff. Stuff. All right, rational expression, which I just showed you. It's not, just gonna be stuff that we end up doing some canceling on. Most of this is rigmarole that no one really cares about. There's a canceling part. Let's get started on some problems today. Yeehaw! The excitement is amazing, isn't it? As we learned about pi yesterday. Wasn't that fun?
Yeah.
Figuring out really what pi was? That ratio? Okay, cool. All right. Now, I'm gonna do this one like really the long way the first time, just so you can see. So really 10 would be what? 2 times 5, and then times 1, 2, 3, 4, 5, 6, 7, 8. Last night I had some BOGO's chicken. Oh, I love the BOGO's chicken. It's 10 for 10 on Tuesdays, and I always get 10. I call the North Canton, I live up that way, so I call the North Canton BOGO's. The lady answers the phone. Mr. Grubb, how you doing? You want your 10 for 10? Yes, sir. 10 chicken tenders for $10. And their tenders are really good. 6. 2 times 3. 1, 2, 3, 4 X's, right? Now, in no way do I want you to write them all out like this every time, okay? We're just doing this first one this way so everybody can see what's going on. What's the theme of the day? Cancel. So let's do some canceling. All right? If we have the same in the top and the same in the bottom, shada boom, shada bang. Get rid of those, and those. End up with 5x to the 4th over 3. Now, if you want, you can do it that way, but you might be able to just look and see what? Well, let's simplify 10 over 6. 10 over 6 is 5 over 3. I have 8 x's on top and 4 on the bottom. There's only 4 left on the top. Boom. Theme of the day. Cancel. Seems like the theme of America. What is it? Cancel culture. That's the new word, right? Cancel culture. Dr. Seuss is out now. Did you guys see that?
Yeah.
How about that? Green eggs and ham. Sam, I am. I read that Dr. Seuss book for my grandkids. It's kind of pretty good. Now, we will step up a little bit. We're still going to cancel, but we have to factor. Sometimes we have a trinomial. Now, these aren't real hard factorings. And then the second thing we're going to have to do is identify where we're undefined. So if you're going to write something down right now, undefined is any number that makes the denominator go to 0. Undefined is any number that makes the denominator go to 0. Sam, I am. 3 eggs and ham. I wish I had a Dr. Seuss shirt. I'm going to get one. I think I'm going to get on Amazon or Sam, I am. All right. So first we got to do some good old downright factoring. Everybody's favorite. Minus here tells me one's going to be plus, and one's going to be minus. Doesn't matter. Factors of 2. Come on, there's only what? 1 and 2 is it, isn't it? So 2 is going to have to be the positive. We still okay there? A simple factor. Now the next one's not so bad either. 3, there's only what? 3 and 1's the only possibilities. So this is also a minus. So it's going to be x minus something and x plus something. And it looks like our plus needs to be the 3. Okay. So this is a little different than the first one, isn't it? We have an expression where we have to factor. We're still going to do the same stuff. So step 1, we got to factor this bad boy. Factor. Okay? Now step 2 is where is it undefined? Okay? There's certain things x cannot be. There's certain things x cannot be, and it cannot be anything that makes the denominator go to 0. So basically, we're gonna set these two guys up down here and set them equal to 0. So x minus 1 equals 0. Solving here, I'm going to add 1, so x cannot be 1. Because if I put 1 there, what's 1 minus 1? Of course, that's 0. And then 0 times all the rest of that stuff is 0. So there's one number that we have to eliminate from our domain. Remember domain? It's the input, the x values. Is there another one? Well, yeah. We got to take x plus 3, set it equal to 0, minus 3. So x also cannot be what? Negative 3. So that is where we are undefined. Cannot have those numbers in our domain. X cannot be those numbers. They're out. Makes sense, everyone. Now we're down to the last thing of the day and the theme of the day, which is cancel. Can we cancel anything? We certainly can. Boom, boom. So we've simplified this to just x plus 2 over x plus 3, and x cannot be what? 1 or negative 3. That's a good thing right there. Step 1, we got to factor if we can, right? Step 2, find out what? Where we're undefined. And that's only what? Where the denominator goes to 0. Okay? And then step 3, theme of the day. Cancel. Goodbye, doctors. Oh, Mr. and Mrs. Potato Head too. I saw that one over the weekend. Did you guys see that?
I'm eating potato right now.
I have a Mrs. Potato Head and a Mrs. in my grandkid playroom. All right, here you go. It should take you about 15 seconds to do this one. Okay, if you want, write it all out and then scratch lines through it, but I think you can do it a little quicker than that, can't you? 16 over 8 simplifies to what? 16 over 8 simplifies to what? 2. And I got a lot of x's on one side more than the other. Where are they at? I got more x's on top, so I'm going to cancel 2 on top and 2 on the bottom, and I end up with it 2x to the 9th. 2x to the 9th. Roger that, everybody? Feeling okay? Let's go back to another one where we might have to factor. Everybody good here? Okay. It's a hard factor because of the coefficient, but look at the problem. It's usually probably going to be one where I cancel, okay? So I'm probably going to end up with 3x plus 4 on top, which I have. What do you think one of them down here might be? Think of it, it's probably going to be 3x plus 4. So what would that leave for the other one? Well, I need an x. And what am I get a negative? It's probably going to be negative 1. You might want to FOIL that out and check. But you see what I was showing you there? We probably set the problem up so it cancels because that's the theme of the day. But yet, it was a hard factor with the lead coefficient of 3. Now I would FOIL that out and make sure 3x times x would be 3x squared. That's going to give me negative 3x. That's going to give me positive 4. Yep. So the middle is plus 1. And yeah, so that's good. All right. So we got it factored. That was step 1. Where are we undefined? Okay. So set these equal to 0 down here. Tell me where they're undefined. Set them equal to 0. You guys know 2 weeks left in this 9 weeks. 2 weeks. 2 more days and 2 weeks. You're checking your grades. You need to retake something. Time to do so. Come in, I'm here. Come in, if you're ready, just come in. All right. So x minus 1 equals 0, plus 1 plus 1. X cannot be positive 1, right? Then we have 3x plus 4 equals 0. Take the 4 over, you'd have 3x equals negative 4. Divide by 3. X cannot be negative 4/3. Those are your two cannot be's. Why are those the cannot be's? Because it makes the denominator do what? Go to 0, okay? And that would be undefined. All right, last step, theme of the day is what? Cancel. Boom, boom. Now, careful here. We eliminated everything on top, so we still have to have what up there? A 1. So this is really 1 over x minus 2. X cannot be 1 or negative, whoops, negative 4/3. How we doing, everybody good? I'm ready to move on, you guys good? Feel okay about that? Alrighty, I had a couple more to do, but we'll catch some of those in a second. Yeah, I'm gonna do this one more. Okay, so we'll do this one. Now, you wanna put the thing in standard form, but sometimes it helps to factor out negative 1. So if I take negative 1 out of this top equation, it'd be left with x squared minus 4. And then I still have x squared minus 2x minus 8. So you gotta look sometimes, especially if there's a negative in front of the x squared. They're hard to factor, aren't they? So make sure you take negative 1 out, we gotta take it from everything. Okay, so if you're losing that just a little bit, we end up with negative x squared plus 4x. If I take out a negative 1 or divide everything by negative 1, I end up with x squared minus 4x, okay? But I still need to have that negative 1 out front. Does that make sense, everybody? So it's just a little added step before we say factor. Now we're ready to factor. Let's see. Still have negative 1. That's the difference of perfect squares. X plus 2 minus 2. I can't see that green, so let's change. And then we're going to end up down here. We got minus minus. And we need factors of 8 with a difference of 2. It'll be 4 and 2. How we doing? Is everybody okay? Now, where are we undefined? X cannot be what? Can't be 4 and it can't be positive 2. Now we're ready to cancel. Cancel, cancel. So our final guy is going to be negative 1 out front. X plus 2 over x minus 4. We good? Everybody sees sometimes take that negative 1 out helps, especially when x squared is negative, that's like a red flag for you to pull that negative out. All right, let's move on. And that is, we're going to move to multiplying, okay? Multiplying and dividing. Multiplying is the theme of the day. Cancel, cancel, cancel. Okay? Remember, when you multiply numbers and add the exponents. Sometimes it's good to multiply them. Sometimes you might just want to try to cancel. All right? Well, this is a monomial, so I'm just going to multiply 3 times 10. Oops. 3 times 10 gives me 30. Okay? Add the exponents, I'm gonna get x to the 8th, y to the 7th. 2 times 9 gives me 18. X to the 5th, y to the 12th. All I'm doing is multiplying numbers and adding exponents there. And we can do that all along if we want, especially if they're just single monomials like that. So now we're ready to do what? Theme of the day. Cancel. Although we do need to simplify 30 over 18. What's 30 over 18 simplified to? I think 6 will go into them, won't it? I think it ends up being 5 over 3. All right, we got a bunch of x's on top. Where do we have more x's? On top. How many more x's on top than the bottom? 3, so that's what's going to be left. Where do we have more y's? In the bottom. How many extra down there?
5.
Yep. Bingo. Very similar to what we've been doing, right? Very similar to those couple problems we did. And letter B is going to be the same also. Okay, but we might have to factor. You do want to put these around binomials so you don't think about just canceling, because you really can't until you get them as multiplied. Okay, so let's move on to letter B. So up top we got x minus 3, and we have x plus 5. And we got a little bit of factoring to do on the bottom. See what you can do. We'll take a GCF out on that first one, 4x plus 20. Take a GCF, which will be 4. The next one, x squared minus 9, is what? Difference of perfect square, so it goes pretty quick too. Now there is one thing up there that's very helpful to us. It says assume that all expressions are defined. That's good, isn't it? We don't have to worry about what? Where the denominator goes to? 0. We don't have to worry about that. It says assume all expressions are defined. So we're good to go. I'm not going to worry about that. I'm just going to factor this bottom and then do some canceling. So I'm going to take 4 out and be left with x plus 5. I'm going to get this down to x minus 3 and x plus 3. And now I'm ready for theme of the day. Questions so far? Shaboom. Boom. Okay, now, careful, careful, careful. If we can get rid of everything up top, what do we got to hold up there? With a 1. So this thing does simplify to 1 over 4 times x plus 3. Multiplication. How are we doing? We got one more thing to show you, and that's division. But the good thing about division, it's the same as multiplication, except we do one thing just a little different. Last couple of problems, how are we hanging in there, everybody? Okay, these are more multiplication problems. I'm going to get to a division. So here we go. We have 5x to the 4th over 8x squared y squared. It's division. We're going to turn it into multiplication by taking this second one and inverting it. So it's going to be on top would be 8y to the 5th over 15. So how do we handle division? We're going to take the second rational expression and always do up to it. Flip it, and now it becomes multiplication. So now we multiply numbers, add the exponents, and theme of the day, cancel. See what you can do. Multiply numbers, add exponents, cancel. Of course, you'll be simplifying a little bit too. Now there is a quick way here. I know I said multiply numbers, but look, if I have an 8 on the top and an 8 on the bottom, what can I do with them? I just get rid of them right away, and that saves me a little bit of a hassle. You with me? You don't need to do that, but it's a little quicker. I'm going to end up with 5 over 15. I'm going to end up with x to the fourth on top, y to the fifth, I'm gonna have x squared, y squared underneath. So those 8s were staring at me. You know, I just knocked those things out there. Just like the Bogo's chicken I had last night. All right, simplify the number 5 over 15, of course. That'd be 1 over 3. Where do I have the most x's? On top, how many is up there then, left over after I cancel? 2. Where do I have the most y's? On top, how many is left over? 3, I think. So we won't really put that 1 there, most likely. We'll write it like that. So division is the same, we just do what? Flip it and multiply numbers at exponents. Now, if you have a division of rationals that you need to factor, you would do the same thing, right? You would flip it and then factor and cancel like that right there. I'm not gonna make you do this one because there's a lot there. You see what I'm saying? Okay, we're just gonna flip this second one. Becomes multiplication. Lots of factoring on these. Cancel. Now look, this is nice. Pay attention. If it says that, I don't have to worry about where the denominator goes to 0. You understand that? It says not to worry about that. Feel okay? I want to give you some time to knock out a couple problems on the homework, so here you go. This is through 14, 2 through 14. Not all those, 2 through 14, and thank you very much.
There's so many women that have
Sorry about that.